Hi guys, it's Miss Wilson here. We are going to go over volume and I'm going to go through your guided notes with you. This is hopefully going to be helpful for those of you that might have been absent the day that we went through these notes, or those of you that might be needing an extra review. I'm at home. I'm not recording in class like I normally do. So with that being said, if I am going too fast, please feel free to pause and go backwards. That's the beauty of YouTube. You can watch it as many times as you need to. We're going over the learning target. I can correctly use the metric system to measure volume. More specifically, I can use and read a graduated cylinder. And we're getting practice in that second part in class. So hopefully if you're uncomfortable with the graduated cylinder, hopefully you're getting more practice and you're taking advantage of those opportunities in class. So as we look at first, we always like to compare English versus metric because you are more familiar with the English typically. So as we look at which is larger, 1 liter or 1 gallon, if you think about where you see liters versus gallons, gallon is bigger. So we're filling in number 1 and number 2 on your notes. So 1 gallon actually equals 3.79 liters. Then as we go to number 2, we look at 1 liter or 1 quart. This one's a little bit harder for you all as we've gone through the notes. But 1 quart is actually bigger, and it's just barely bigger. So as you look at your notes and you fill in number 2, 1 quart equals 0.946. And be careful as you fill in your notes because as you look at it, it is out of order, and I apologize for that. So that's actually the third one in number 2. And 1 milliliter or 1 fluid ounce, you might think of your can of pop. 1 fluid ounce is bigger. Your typical can of pop is 12 fluid ounces, and that's usually about 355 milliliters. So as you fill in number 2, 1 fluid ounce is equivalent to 29.573 milliliters. So hopefully you've got number 1 and number 2 filled in. Again, we need to focus on the metric system. So as we look at which of these units are metric, okay, liters and milliliters is what our focus is going to be on. But it's always good to have that visual with the English system so that you can kind of compare mentally. As we go to number 3, as we look at volume, volume is the amount of space an object takes up. So there's number 3 in your notes. Okay, as we look at volume, can't confuse it with mass. Mass is the amount of matter, while volume is the amount of space. So our base unit, and what we went over that last slide, that base unit is the liter, and it's represented either by a capital L or a lowercase l, and I'm really going to encourage you to use that capital L because a lot of the times we confuse that lowercase l with either an I or a 1, and so that will help you from being confused. So as you're looking at your guided notes, hopefully you have the whole front side of your notes filled in, and we're going to go to the back to number 5. Again, if I'm going too fast or you miss something, go ahead and rewind back and listen to it again or pause it. So as we look at number 5, we're talking about a liter, and I had a cube in my classroom, and we talked about the cube that I had, and I've got a picture over here of this cube as we look at this picture right here. So when we talk about what a liter is the volume of a cube that has 10 centimeters on each side. So there's number 5. I'm going to underline this 10 centimeters. And the cube in my classroom, so since you're not there right now, I encourage you to look at that. But that cube, if we were to take it and fill it up with liquid, it would hold 1 liter. And so each side is 10 centimeters. And so moving forward with that visual, when we talk about 1 liter and what that cube would hold, we can move on to number 6 in your notes. 1 liter equals 1,000 milliliters. And so you're starting to make that connection as we've looked at the other units. Oh, I underlined the wrong thing there for you. So we've got 1 liter equals 1,000 milliliters. And then for the second part of number 6, 1 milliliters equals 1 centimeter cubed. And when we're talking about centimeters cubed, we're talking about solid volume. So we've got 2 different volumes that we'll be talking about for this. We're going to be reminding you about liquid volume and solid volume. And right over here, we've got a little bit of a fun fact. We've got 1 gram. Now, as you look at that, that might throw you off because you might say, Miss Wilson, we're talking about volume and not mass, but gram is mass. If you look down here, when we look at that star, okay, it's a fun fact when we're referring to water. So if I were to hand you 20 milliliters of water, and you might just want to write in your notes, oh, let me switch to pen, water. Okay, so if I were to hand you 20 milliliters of water and ask you the mass, you shouldn't have to take it to the triple beam balance. You should be able to tell me, well, if it's 20 milliliters, then Miss Wilson, it's 20 grams. And so there's that direct relationship between the two, which is nice, and it's a good fact to know. All right, I want you to take a minute and look at number 7. I want you to pause the video, and I want you to go through and try to figure out which one is larger. So go ahead and hit pause for just a second and then play when you're done. Alright, so hopefully you hit pause and you've looked at each one. So number 7 for A, when you look at 1 liter or 1,500 milliliters, hopefully you guessed 1,500 milliliters is bigger. Your justification, because I always ask you in class why 1 liter equals 1,000 milliliters. So if we're just writing a note, and I don't have my stylus, so this is going to be sloppy. So when we look at that, 1,000 versus 1,500, 1,500 is bigger. Looking at B, 200 milliliters or 1.2 liters. Hopefully you said, well, 1.2 liters is 1,200 milliliters. And so, therefore, when we compare those two, we've got, and you should have 1.2 liters is bigger. And then the last one, 12 centimeters cubed or 1.2 milliliters, and that's when we're talking about water because you got that star there. 12 centimeters cubed is bigger because that's the same thing as 12 milliliters. Okay, or 1.2 milliliters is the same as 1.2 centimeters cubed. So if I give you some liquid and you are to use a tool, the tool that you're going to use is what I got right here, this picture of a graduated cylinder. So we're moving on to number 8 in your notes. So graduated cylinder helps us define the volume of liquids, and it helps us define the volume of other objects, and we'll talk about that here in just a minute. But you'll notice as you look at this picture that I've got here, there's this curve. When we talk about that curve, that natural curve happens in any graduated cylinder that you're going to have, and that curve is called a meniscus. Okay, meniscus. When you're looking at that eye level, you should always see the curve. And so when you're reading a graduated cylinder and you're trying to be as precise as possible, we always look at the bottom of the curve, and that's right where that arrow is pointing to. So as we look at it, if I were to ask you to find the volume of this picture right here, take a minute. Make sure you're looking at the bottom of the meniscus. What do you think the volume is? All right, hopefully you looked at that center and you didn't tell me 43.5. Hopefully you told me 43 because it's 3 notches above the 40. Some of you might be curious as to why that curve is caused. It's very similar to when we did that magic show trick with the surface tension. That water molecules, they stick to the side of the graduated cylinder, and it's even more noticeable in glass graduated cylinders. So that liquid sticks and it causes that curve. All right, as you look at your notes and you look at number 10, your pictures, I'm going to apologize. The copier did not give you good pictures like I've gotten in the past. You'll notice that these pictures don't have the curve. They don't have the meniscus, but I want you to pause this video, and I want you to go ahead with the graduated cylinders. And looking at my picture that I've got right here, I want you to figure out what the volume of each graduated cylinder is. Be very careful that you pay attention to the scales. Each graduated cylinder is a little different. So pause it. All right, hopefully these didn't trip you up. So as you look at A, and correct it as you go if you need to. So we look at A, it is 2 past the 50. Now, I had a couple of students in class wanting to tell me that it was 50.2. If we're looking at the scale, we notice that 60 is up here, so it's between 50 and 60. So hopefully you wrote 52, and don't forget your units. You got 52 milliliters. On this next one, it's a different scale, so you'll notice it's going up by 5s. So hopefully you got 37 milliliters. And next, this last one might have been a little bit tricky. It's hard to be precise with this one, so you got to use what you know. And you'll notice that it's going up by 5s, but there's only one little mark there in between the 20 and the 25. So that mark represents halfway. So essentially halfway, that represents 22.5. And you'll notice the liquid is a little bit above that. So a good estimate for that would be 23 milliliters. All right, so we've gone over liquid volume, but what if I give you something solid? Specifically, we're going to talk about cubes. There's always different formulas, and when it comes to state testing and things like that, you'll always be able, hopefully they'll always give you the formula. But when we're looking at regular objects, we always use, for a cube or a rectangular prism, we're going to use the equation, and I want you to write this in for number 11. Length times width times height. So there's number 11, and as we look at number 12, it wants to know what is the volume of the cube in this picture. Now these numbers are pretty interchangeable, and it doesn't matter which order we put them in, but we've got 10 times 8 times 9. So 10 times 8 is 80. 80 times 9 is 720, and the key is, and the biggest thing I've been trying to remind you this whole unit, is that you can't forget your units. And because we're multiplying 3 things, we're multiplying length times width times height, that should help you hopefully remember that your units are not just centimeters, but we multiplied 3 things together, so it's cubed. It's 3-dimensional. So hopefully that will remind you when we're using volume, it's centimeters cubed. All right, so let's look at 13 and 14. And 13, you're going to have to put this in your words, in your own words a little bit. So what happens if I hand you something that's an irregular shape? It's not a perfect cube, or it's not a rectangular prism, or it's not a cylinder, but it's an irregular shape. We can use what we call water displacement. So I'm going to explain water displacement, and as I explain it, you may or may not need to pause to fill in number 13. But we're going to fill up a graduated cylinder with water first. That's step number 1. And then we need to make a note as to how much water we actually put in the graduated cylinder. Then we're going to drop the object in, And we're going to pay attention real closely to how high it went up, and we're going to record that number as well. So we've got the amount of H2O without the object. It looks like it's 200 milliliters. And then when we put it in, it looks like, to me, it looks like afterwards, it's 260. And so from there, we're going to do the math, and we take the amount of water with the object, and we're going to subtract the amount. Ooh, I got a typo there. All right, we're going to take, again, the amount of water with the object, and we're going to subtract the amount of water without the object. And so the difference is 60. Don't forget your units. And in this case, ooh, I wrote the wrong unit down. If we look at our graduated cylinder over here, we can see that it's centimeters cubed. So for some practice, you can see, and Miss Wilson will link that link for you, so there's more practice there. So as you look at your notes, you should have all of your notes filled in. All right, I'm going to see if this will pull up. Alright, it looks like it's not going to pull up. So I will link that in my post with it. So if you're needing some extra practice with volume, there you have it. So I hope this finds you feeling a little bit better about volume and having your notes completed. As you look at your learning target, I can correctly use the metric system to measure volume. More specifically, I can use and rate a graduated cylinder. If you struggled with the lab that we did in class with the graduated cylinder, by all means, you may come in AE. Just make sure that I sign your planer, and you are more than willing to get some extra practice in measuring, because you will have a skills-based test as well. All right, hope this finds you doing well, and I will see you later.